Hi, I'm Maggie van der Oever. I am a junior at Spring Hill College and I'm majoring in mathematics. Today I'm going to present a program coded in Dr. Racket that approximates pi. I will first be going over the computations, like the math part of the program, and then I will show you the program in Dr. Racket. So let me share the screen. So imagine we have a big square like this. For example, laying on the ground, in which we include a circle. Let's say the square has a width and height of r, and which makes the radius of our circle r/2. So let's imagine this square and circle are on the ground, and we are just randomly are gonna throw balls in there. So just randomly are gonna throw them in there, and they fall wherever they wanna fall. It's gonna look like something like this. And we can go on for a while like that. So while doing this, we can calculate the probability of us throwing a ball into the circle. So let's, instead of balls, call them dots, since they look like dots in our picture. So the probability of dot landing in circle is going to be equal to the area of the circle over the area of the square. So we know that our radius is r/2, and the area of the circle is going to be pi r². So that gives us pi let's see, r², since we're squaring the numerator and the denominator. So r² times, or over 4², which gives us 4, over the area of the square, which is just height times width, which is r². So we can simplify that a little bit further. Gives us, let's see, pi times r² over 4 times 1 over r². So as you can see here, the r² cancel out. Which leaves us that the probability of a dot landing in the circle is just pi over 4. So if we multiply both sides by 4, we can estimate pi as follows. Let me change it to blue again. So we're going to estimate, so the probability of the dot landing in a circle times 4 is equal to pi, which we can calculate by 4 times the number of dots in the circle over the total number of dots that we have thrown into our square. So that's how we're gonna do our calculation to approximate pi. So for example, if we look at the dots that we have thrown in this example square, then it would have been 1, 2, 3, 4, 5, 6, 7, 8 is the total number of dots, or 10 is the total number of dots, and 8 is the number of dots in circle. So we would estimate pi as 4 times 8 over 10, which obviously is not that close to pi. And this is mostly because since I was just picking my dots, like it's really hard for me to randomly pick. Like you're biased by, oh, like I already picked one dot like in that spot, so I'm gonna put now one dot there, and it's not completely like random. So this is a problem that I had while programming too, and that's why I decided to use the random function in Dr. Record. That I use that as it where it generate random points and would include those in the square. So let's actually look at the program. So I'm gonna share Dr. Record, and let's first start with just running the program so we can see what it does. I will have to share that particular screen. So I ran the program and we got to see this. And so you see the square and the circle within it, and the number in the middle is its approximation of pi, which keeps changing as dots get added, since that's how it's calculated. So I'm just gonna let this run while I explain the program. Okay, so I first started with designing our visual component. So that is this upper part you see. So I defined a border, which is just an empty scene. Within there, I defined a square that has a black outline. I defined a circle with a black outline. And I defined the dot, which is a circle, solid red. And as we can see, our radius of the circle is 250. So the height and the width of our square is 500. And then I defined a dot structure, which takes in an image, which actually is the image that we just saw. It takes in the x coordinate of that specific dot, the y coordinate of that specific dot. The first number represents the total number of dots in the square, and the second number in C, represents the number of dots in the circle. So let's go down to here, which is actually the main function that represents the visual and the calculations that we just saw. I use the Big Bang structure of Dr. Record, which takes in a state of world and creates some other state of world. As you can see, like, so it's basically, it has 3 different options. So it can use clock ticks. So on every clock tick, it will represent a new state of world. Or it can use mouse events. So on every click of the mouse, it generates a new state of world. Or keyboard events. So every space it generates a new state of world. So I use on tick. So every clock tick of the clock, it calls the function reset dot. So let's look at that function, which is right here. It basically just overlays a bunch of images. So it first overlays, let's see, it first overlays our circle with our text. So it has the circle and then the x coordinate, the y coordinate of where the text is overlaid in the circle. So it's gonna output text and then get approx. So that is where our calculation that we saw earlier comes in part. So that function is up here, and it is, so we can see here, takes in the number of dots in the circle, divides it by the total number of dots, and then multiplies it by 4. And it converts it to a string. So that is overlaid, so it's pasted onto the circle, which is on their part pasted in the border, with the image property of the dot structure. So that's basically creates the image. Oh yeah, so that creates the image, which we actually have called with the toDraw function. So on every tick, it is gonna reset dot. So I actually looked at the wrong one. So this is our reset dot function. So it has defined 2 local variables. That is basically a random value for x, a random value for y. So it creates a position, and it generates a dot structure that so it overlays the dot in the image. So that's this dot, the circle solid red. And it records its x coordinate, its y coordinate, and it increases the total number of dots by 1. And it checks whether the circle is, whether the dot is in the circle or not. If it is in the circle, it adds 1 to number in C, otherwise it doesn't. I made a sub function for that as well, which is right here, which is basically just the distance formula, and it checks if the distance is smaller than its radius of the circle. Let's see. So on every tick, it's going to reset dot, which is just, it makes a dot structure, a new dot structure. And that's based on this random values for x and y. And then it calls toDraw, where it does the scene dot function that we just discussed. So it's actually going to overlay the dot image in the circle with the get approximate. And then, so that's basically all the visual stuff we just saw. And then I added this state to state functionality in the Big Bang, which is gonna generate the following screen. So that is generating this screen. So I hope you're seeing it. Yeah. So that is, so the last two numbers here, the last number is the number of dots in the circle, and the number before that is the total number of dots. So the program has ran for so long that we have 1,050 total numbers, and 850 of those are in the circles, or in the circle. So let's go back to our actual output of the function. So we can see that a lot of dots were added, and our approximation right now is 3.22. And as it keeps adding dots, this will get closer to pi. So that is the output of the function. In general, as I said before, I came to the conclusion that it was better to use random variables instead of like picking. So I first made a program where I used the mouse clicks to pick a dot in the circle. So I was able to pick dots, but the approximation of pi was not as good as it is right now with the random variables. And then another thing that I saw, so first I had a smaller square and a smaller circle, so the radius was smaller. And it took way longer for the approximation to get closer to pi than where I now have the radius set to 250. I think before I had set it to like 100. So those were two things that I improved in the process. And then at the overall, I think what I can still improve is how I generated the overlays. So what happening now is in the dot structure, it has the image property, and every time it makes a new dot, it overlays a new dot in the image we already had. So I start with just a circle, I add a dot, I add another dot, I add another dot. So you can imagine after 1,000 dots, this image is super big, which affected the speed of the program a lot. So that is something that I can improve in the future. And that was it. Thank you so much for listening, and I hope you have a great day.